So we are going to look at this paper whereby we are going through Unit 4 Physics, IAL and Excel. The first question, students were asked to state which of the following shows the electric field around a proton. So what you need to understand is that a proton is positively charged and is going to be considered as a point charge. So if we are talking about a positive charge and then that is a point charge, then it means that the fields are going to be radial and they are always directed away from the positive charge. So in that case, we are going to look for a diagram that looks like that. So you can see this one must be a negative charge. That's why the fields are coming that way. But this should be a positive charge, so the correct answer there is A. So, and the reason we are saying that is electric field lines around the positive point charge should be radial outwards, but for negative they should be radial inwards. And but for a current carrying conductor, the fields should be concentric, circular. So in that way, for instance, this is wrong because you see the spacing here. As you move away from the conductor, the strength of the electric fields keep on increasing. So for this case, if maybe the current was coming out of the page and you use right hand grip rule, the field will be looking like that. So currents coming out of the page and the field will be pointing in that direction. So something that you ought to remember is that the separation keep on increasing, which means that the fields becomes weaker as you move out of the conductor. So in this case, the correct answer that the examiner marked was supposed to be A. Now let's move to question 2. And question 2, we are told in the sun, two protons can combine to form protons. Two protons can combine to form a proton, a neutron, and another particle X. Which of the following particles should be X? So the reaction is P plus P, right? So proton plus a proton, we have a proton plus a neutron, then plus X. Okay. Which means that charge here, we have a positive charge because for reaction to take place, charge must be conserved. So this is a positive charge plus positive charge, and then we have here positive charge, and then this neutron is usually no charge, 0 as no charge. Then it means for this reaction to take place, we must have X having a positive charge. Okay, so charge must be conserved. So which means that the charge of Q, the charge of X is going to be positive 1. So that's one of the things that we need to point out. And we need also to look at the conservation of the baryon number. And since we are having protons here, we are going to say the baryon number must be conserved. So meaning the baryon number, in this case baryon number, before the reaction was 1 plus 1, and after the reaction we have 1 plus 1. The neutron, right, is the baryon number of a neutron is 1, so which means this must have a baryon number of 0. So because we are saying plus bx, so which means that bx, baryon number of x, must be 0. Therefore x is a positively charged meson, so we can be able to say x is a positively charged meson. Conclusion: is positively charged meson. So in that case, we can say the answer is D. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime we're going to upload more tutorials, you'll be notified. In ProfLearn YouTube channel, we do maths, and physics. So if we are taking pure math, you are taking mechanics, you are taking physics, unit 4, 5, you'll be with me here for you to learn. Just consider subscribing. Okay, so moving to the next part, we are told in the next question that alpha particles pass through small thickness of absorber. The momentum of alpha particle is halved. The initial kinetic energy of the alpha particle is E. Which of the following is the kinetic energy of alpha particles? Which is the kinetic energy of alpha particles? So what is the first thing that we need to remember here? We need to remember a few things. Number one, that kinetic energy is given by the formula P squared over 2m. So that's one of the formula that we have to remember, where m is the mass of the particle and p is the momentum of that particular particle. So once we have identified that, we are told that alpha particle, if p is halved, what's going to happen? If p is halved, because the mass will remain the same, p is halved, so it means that we're going to have p over 2 squared divided by 2m, and now that is for instance, if that's the kinetic energy 2, yeah, so we shall just let it denoted with E2. So that's going to be P squared over 4 divided by 2m. Then if we want to get rid of this 4 that we have here, we are going to say times 4, also down here times 4. So if you work it out, you're going to get this being P squared over 8. And basically I can decide and write this as P squared over 4 2m. But remember, kinetic energy is given by P squared over 2m. Therefore, if the initial kinetic energy was equals to P squared over 2m, then I can be able to say P squared over 2m is E. So which implies that our new kinetic energy is going to be 1 over 4 times E, because all of this part that we have at this point here, this part that we have here is basically E. So finally our answer now becomes E over 4, and E over 4 is